Hi, everyone. We're just going to take another minute or two as people are still joining us. So hang tight and we'll get started. Okay, so we're going to get started. Hi, everyone. Thank you so much for joining us on this great webinar we're hosting. We're especially excited about this one as it's turned out to be one of our most popular webinars to date, and because we have a great guest speaker presenting, Jared Lander, the author of R for Everyone, Advanced Analytics and Graphics. Also joining us today is Evan Castle, our wonderful product manager here at Sisense. Evan, why don't we get started?
Okay, great. So it's fantastic to see so many people joining today. My name's Evan. I'm part of the product team here at Sisense. And I'm just going to start off by giving you an overview of what we'll be discussing and what you can expect from today's webinar. So first of all, we're very, very excited to have Jared joining us today. So we're going to introduce Jared along as Sisense, for those of you who don't know who we are. We're going to be talking a little bit around how we came up with our integration around R and what we learned from the market and from everybody's needs in doing it. And then we're going to actually talk through a process of anybody who's actually looking to get started with R, what they should be doing and what the things that they should be focusing on. And then we're going to do a real-time live statistical analysis that Jared's going to walk us through. And then we'll have some time at the end for some questions. So just to introduce you, I'm sure many of you are familiar with Jared. Jared has one of the preeminent analytics firms here in New York. He's the chief data scientist. He works with doing consulting around statistics and predictive analytics for both small and large organizations. He also has the best-selling book on Amazon, R for Everyone. And I think more importantly, I think he's a fantastic teacher. He doesn't only know, obviously, the requirements and the academic perspective, but I think he's really an excellent consultant and somebody who can deliver the value around R. And of course, he's a host to one of the largest R meetups and conferences held as well. So Jared, just to begin with, can you tell us a little bit about the kind of statistical work and consultation you do with organizations and what you've learned specifically around organizations looking to get started with R?
Yes, we do work with, as you said, all sorts of businesses, whether it's a large investment bank or an NFL football team or hospitals, marketing companies, food processors. So every type of company really is an entirely different challenge because they have different problems they want to look at. But what it all comes down to is using data to derive information. And most of the time, we always like to say, start simple, let's use a regression. Because that will knock out 90% of your problems. So we always really push, hey, something that's easy to do and explainable.
Okay, great. So let's just introduce everyone to just a brief overview of who Sisense is and what we'll be showing today. So Sisense is a business intelligence and analytics platform that has been specifically designed to simplify business analytics for complex data. And when we mean simplify, we provide a full solution, so the ability to both prepare, process, and analyze and share data. And we do it in a way that enables people to rely less on IT and to deliver results within a few days rather than months or years. We're talking about complex data, and this I'm sure is a lot of an issue that many of you have on the call today. We're talking about many different types of data sources and very large data sets. So when we started working with a lot of our customers, they were asking also to how they can get started using R, either to perform more advanced statistical analysis or to do some kind of prediction. And there's a few things that they were asking for around that. The first was to implement a much broader range of statistical functions, and obviously R has an incredibly and varied range of statistical tools. The second thing was that they were working with lots of data sets, and they wanted to make it easier to kind of centralize that data, to automate the data preparation, to be able to run statistical analysis on it on a more frequent basis. And lastly, they wanted some tools around reuse to save and use those models. So the solution we provided did a few things. It enables anyone to start using statistical functions through R, simple functions like k-means, clustering, apply more predictive models, as Jared said, using linear regressions, build new models with Sisense data, and then run those models using existing data so they can make predictions as new data comes in. And lastly, to be able to quickly prepare data. So Jared, I think what we'd like to maybe start off with is, you kind of touched on this earlier, but what are the types of statistical analysis you recommend for companies getting started with more predictive analysis and R?
So I believe it's always very important to, as I said earlier, start simple. Start with a linear regression and start with just a few predictors. See how they do. Get to understand what's happening in your data. Before you can even do that, though, you have to explore your data. There's a term called exploratory data analysis, EDA. This is where you visualize your data and munge your data. The munging is preparing it for analysis. That might mean cleaning up the data, reshaping it, just creating new features. And it is an iterative process where you visualize your data, you see what's wrong, you munge your data, and you go back to visualization. I can't stress enough how important visualization is. Next up.
So, go ahead. Sorry.
No, go ahead, Evan.
Okay. No. So I just wanted to emphasize here, Jared's going to walk us through the 4 steps that he thinks are very important for predictive analytics, and then we'll use this to around the demo. So sorry, Jared, go ahead.
Not a problem. And reiterating what I said before, you can see how often I say this about starting simple. It used to be maybe 10 years ago, maybe 15 years ago, that building a model was hard, and you had to write a lot of complicated C code, maybe C++. So you really wanted to perfect your model ahead of time and then code it up. But now with R, it is so simple to fit model after model after model that start with something simple, and then we can grow from there. So start with a basic regression model, just a few predictors. After that, you're going to want to visualize your results. And again, we talk about visualization a lot. Most people just talk about visualizing the data. But it's very important to visualize your results. You could have the best analysis in the world, and it won't matter if you can't understand what the analysis is doing, and more importantly, if you can't communicate that analysis. So you see what happens in your data, you understand your model, and then you iterate. You add more variables. You build it up. And after you've gone as far as you can with the simple model, it's time to move on to more advanced models like decision trees, boosted trees, random forests. All that stuff comes later. After you squeeze as much as you can from the simple model, you go to these advanced models to get that much more performance.
Okay, excellent. So I think these are 4 very valuable tips for anybody to take into account. How easy it is to visualize and prepare data, to start with more simple models and go from there, to iterate and incorporate new predictors and models, and then to move on to the next level for anyone who's looking to get started. what we're going to discuss now is really just exactly show you an example of how to implement those steps that Jared just took us through using Sisense. So in this case, we're going to look at a very simple example, which many of you in a business scenario might be familiar with, is that you're going through the marketing process and you want to try and predict potential outcomes because there's limited resources available, and you want to make sure that you're always focusing on the most valuable opportunities and doing your utmost to be able to convert those into deals, into sales. So in this example, we've taken some data, which would be typical for the kind of person that you'd be talking in a B2B scenario. It might include the authority of the person that is having these discussions with you, what their budget is, what their role in the organization is, and we're going to combine that together to kind of just get an outcome. So we're trying to see, was the deal closed or was it lost? And then we can use this model again to kind of predict, based on future data sets, what is possible. So we can perform that statistical analysis. Again, as Jared said, we're going to go through 4 stages. Exploratory data analysis, to actually evaluate potential variables, data preparation and some of the kind of challenges that may come up around that. We're then going to build and train a model using those variables we discussed. And lastly, we're going to go through a process of scoring to run the model on new data to predict potential outcomes. So I'm now going to just switch over to a live demo we have. And Jared, in this example over here, we can see the first part with the graph on top. How would you choose variables to include in your analysis, and what are we seeing on the screen?
So it's always very important to have some sort of domain knowledge to understand what's happening in the business and talk to people who have been doing it, not necessarily analysis, but who have been in the business to see what they feel is important as a good starting point. Another step is obviously visualizing. And here we're seeing 2 visualizations that are very similar but show us different information. On the left-hand side is a visualization of average deal size based on the level of seniority of who you're talking to at the potential customer. We can see here that manager and upper management are a little higher than the other 2 bars, but it's not necessarily significantly higher. What is more interesting is the chart on the right. This is the conversion rate. This is how often you close a deal depending on who you're talking to. And here we can see if you're talking to an executive or upper management, you're more likely to close the deal. So while there might not be a lot of difference in the deal size, there is a difference in whether or not you're going to close it. And we've seen it visually. So what we want to do next is build a model to quantify this and see how much of a difference it makes.
Okay, great. So in this example, you can really see how important it is to kind of just have that visualization capability and to be able to do it very quickly and easily. In terms of Sisense, everything we do is web-based. It doesn't require anything besides selecting various variables in the data and then choosing how to visualize it. From that analysis, as Jared said, you can see that certain variables are likely to have some kind of association potentially with outcomes. In this case, we can see that the seniority of the person that we're speaking to seems to have a relationship with that outcome. So the next step that we would take from there is kind of understanding what we have to do to get the data in shape. So Jared, in the next step over here, I'm just going to scroll up maybe a little bit so everyone can see what kind of data preparation or managing steps, or maybe you can perhaps explain, is required to start using and actually modeling this data.
So when you're working with data, there are numerous issues that can happen. You could have missing data that you need to account for somehow. You might need to bucket a categorical variable that has many categories into fewer. You might want to square a predictor variable because that way you get a curvilinear expression. There's all sorts of things you want to do. For our particular problem, we want to model the conversion rate based on the seniority of who you're talking to. Now, seniority here is a categorical variable. It's text. It is employee it's executive, it's manager, it's upper management. But when you're doing regression, you're doing math. You're doing linear algebra. You need to multiply and add together your variables. It's very difficult, if not impossible, to multiply text data. So we need to find some way to represent this numerically. So in statistics, what you traditionally do is, if you're fitting a linear model, you convert your text data into indicator variables or dummy variables. That is, instead of having one column that for each row lists either employee, manager, executive, upper management, you create multiple columns. You'd have one column that says, is this person an employee? Yes or no, 1 or 0. You'd have another column, is this person an executive? Yes or no. Is this person a manager? Yes or no. Is this person upper management? Yes or no. Now, right now we have four possibilities. We would only create 3 indicator columns, as we'll talk about later. So here in Sisense, we can see we have pre-prepared the data by creating these indicator or dummy variables. This way we can go and do the math.
Okay, excellent. So what you can see, I think this is important to point out, is these variables didn't exist in the data, so we had to have some kind of ability to make those changes, add additional columns in the data. With Sisense, that's done in a visual environment. So over here we have 2 data sets we're working with. We can easily add additional custom fields to that data, and then we can apply some kind of logic using functions or tools. So in this case, we're categorizing the budget allocation based on different criteria as a 1 or 0. Now, the important thing to note is once that's done, it's actually going to be automatically updated. So obviously, you're not going to only run an analysis once. You've got a stream of data coming in, and you want these transformations to happen quickly and easily. So it's possible to automate that process. So as soon as new data comes in, it's already ready for your analysis in R, and that takes away a whole lot of preparation work you need to be doing to get things up to date. Great. So now that we've got our data in shape and we're ready to start diving into our analysis, how do we start building a model? And I'm just going to scroll down to the next stage over here with the regression, and perhaps, Jared, you can tell us, how do we start building these models and take it from there?
So in R, it is very simple to build a linear model or a generalized linear model. In fact, to call a linear model is just the LM function. It's 1 line of code. And to call a generalized linear model, it's the GLM function, very appropriately named. And what's nice is these functions are nice and simple to call in R, and then they run down in C and Fortran routines, so they actually run very quickly. So the steps are, you have to define your outcome variable, what we call a response variable. In our case, that is going to be conversion. This is a binary variable. It's a yes or no. Did the sale convert or not? And for our very simple model, we're just going to try to predict the conversion based on the seniority level of who you're talking to. So our response variable is conversion. Our predictor variable are the indicator variables for the seniority. The indicator variables have been pre-prepared for us. They've already been made in Sisense, the 1s and 0s. And as I said before, even though there are 4 levels of the predictor variable seniority, we only use 3 of the indicator variables in the regression. This is due to the laws of linear algebra, and we want to avoid multicollinearity. We're not going to get into multicollinearity now, but it's a bad thing when you're doing regression. So only using 3 of the 4 indicator variables allows us to avoid that. And the way you interpret it is you have one baseline, and the values of the coefficients for all the other indicator variables are their effect relative to that baseline. And since our response variable is binary, conversion, yes or no, we have to use a type of regression that's called binary regression, or its more familiar name, logistic regression. What this will do, it allows us to model this binary outcome, and the result it comes back with is a number between 0 and 1. is the probability of success.
Great. So I think two important points to note on this. In a business setting, what we have over here is just a very simple example of a set of potential prospects that we are talking to, and we can build a model to assess the probability that there's going to be a good outcome based on historical results. We can also do this in a visual way, so we can very quickly see high or low probability outcomes. And then once that's done, we can save it to our repository and then reapply it as new data comes in. So everything is reusable once it's done, both being able to save the model and then being able to actually reapply it again. So now that we've got that in place, how can we use that model to effectively predict outcomes going forward?
Predictions, especially in R, is incredibly easy. Once you've built the model and you have this using either LM or GLM, and you have a model object, you can use that model object to score new data. Now, the scoring is very simple. It's an inner product. It's a multiplying and adding two vectors together. Very simple to do mathematically. So it should have a big O of 1 runtime. But regardless of the computing information here, in R, it's as simple as using the predict function. The predict function takes primarily two arguments. The first argument is the model object you created earlier. The second argument is your new data. So you have new information comes in, you have information about the customer, and you take that information and you put it into the predict function, which runs it through the model, and it gives you back a score. It gives you back a number between 0 and 1, which indicates the probability of closing this deal based on who you're talking to.
Okay, excellent. So I think what's important to note here is that the whole process has now been automated essentially. So as new data comes in, the preparation work is done and then it is reapplied. And it also gives you a layer of interactivity. So if we want to focus on a single example, in this case, managers, it can quickly reassess the data and give us outcomes based on that specific item as well. Now, I know a lot of you on this call there's a range of familiarity with R, but what we did want to maybe do is just Jared to walk us through some of the actual script he used just for a minute or two. So we're going to switch over to our slides again. And what's important to note is what Sisense enables you to do is to do a combination of applying R script with Sisense data. So these two scripts are now being shown on the screen. And Jared, if you want to maybe just give a quick overview for those who are familiar with R, what is happening.
So Sisense passes in data as a list of vectors. They did this so you could have generality and you could pass in a much more general set of data. So our very first step here, where it says my data gets data frame, is going through and taking the vectors from this list and putting it into a data frame, because people who use R are familiar with data frames. It's just easier to work with. So that whole first line is just building up a little data frame to make life easier. The second line where it says LR model gets GLM, that's the model fitting step. That one line of code is going to fit us a logistic regression. And we can see it uses R's formula interface. For those of you who've never used R, the formula interface is how you define a model. You can see after the word convert there's a tilde. What's on the left-hand side of the tilde is your response, or your outcome variable. What's on the right-hand side are your predictor variables. So in this case, we are modeling convert on these other variables. Now, earlier we created dummy variables or indicator variables already. So exec, upper, and manager are those indicator variables. And while those are the variables of interest, there are these other variables like biz, tech, and budget that control for variation. Now, we are definitely going to be interested in their effect on the model, but even if we weren't interested, you still want to include those variables just so you can control for the data and get better results on your other variables. The next argument is specifying the data. That's the data frame we created in the line above. And then since we're using GLM, we need to specify we're using the binomial family versus a Poisson family or a Gaussian family, because again, we are doing binary regression. The next step, we're just saving the model to disk, so that way we have it available. We don't need to refit it. It's available to us. The line after that is getting the fitted values from this model. So when you run a model, you have a bunch of training data, and fitted values are the scores for the training data. It's a way of helping validate and see how good your residuals are, which tells you how good your model is. That is the end of the R code. After that, it's more of the Sisense code, and we are telling the Sisense which columns from our cube to pass into R, which become the arguments in the args list that we see in the very first line. So that's training the model. That's how you build your model that you can model your business with. The next chunk of code where it says run model is when we get new data coming in and we want to score the data and see what the probability of conversion is. The very first step is just like the first step in the first chunk of code. We have to build our data frame. This is just a simple step to, again, make it easy to use in R. Line 2 is loading in the model that we had saved earlier. Because this is a separate process, we want to keep things clean. When we train the model, we save it to disk. When we run the model, we assume it's a clean environment, and we load that model from disk, one that we had previously saved. This allows it to persist among different sessions and keeps things sterile. Line 3, that's where we do the predictions. And like I said, it's incredibly simple in R. We use the predict function, which is very well named. The first argument is the model. That's the model object. Hey, we went through, we fit this model with a bunch of variables. We think it does a good job. That's the first argument. The second argument is new data. That's data coming in that you want to score. Really that simple. The third argument is the type of predictions you want to make. Without getting too much into the math, there are different types of predictions. You could do it based on the real number space, which can give you a number between negative infinity to infinity, which you generally don't want when you're doing this type of prediction. Or type equals response, which gives us our score between 0 and 1. This, again, is our probability of converting. And the last line, again, is Sisense code telling the program what columns to pass into R. So you can see the R code itself, fitting the model, well, is one line to create your data frame, one line to fit the model, one line to save it. Scoring your new data, it's one line to create the data frame, one line to load the model, and one line to make the predictions. So it really is quite a simple process to create powerful models.
Excellent. So thanks for that explanation, Jared. Just want to add one point to it. What's important is that these models, once they're created, can be saved and simply reapplied. So all the script that you see over here can be saved almost as a single outcome and then reapplied in analysis or different data or adjusted for different circumstances. So we do want to leave some time for questions, but we did want to summarize what should be 5 tips for predictive when getting started with R. These are the points that Jared mentioned that were very important to take into account for any of you looking to get started with R. The first is to be able to visualize and munge or prepare your data, to start with simple models, to iterate, so to add more variables, then work with more complex models, and again, always very important to being able to visualize and communicate those results. So we do have a little bit of time left. What I'd like to do is now at this point just to open up to questions. So we're just going to go on to just mute for 2-3 minutes. If anybody has any questions related about the analysis we did, R, or questions relating to R, please feel free to pop them in the question box and we'll be happy to address them now. Some of the questions that are coming in relate to Sisense, others relate to R. Jared, if I can ask you at this point, is there anything you would like to address from the questions that have come in relating to R, or should we wait for a few more to come in?
Well, there's one good question about the R server, if it's already installed when Sisense is installed. And I think that's very good because infrastructure is an important thing to do. You need to have your infrastructure ready to make it easy going down the road. And they are two separate processes. You install Sisense, it's one thing, and you install R using its own installer, which both are incredibly simple processes to do. There was a question about, in learning to program R, do we recommend a particular source? Absolutely, R for everyone. The book I wrote is an incredibly great source. And while that is a funny comment, and I do believe it is a good book to read, if you want to learn in person, I'm not sure where this user comes from, but I highly recommend the meetup, the meetups available to you. I know in New York, I run a meetup with 6,000 members. A few hundred generally show up. There's meetups in San Francisco and Chicago and Singapore and Tel Aviv and London. All over the world there's these meetups. And I highly recommend taking advantage of these. They are a great source of education, and they're just a great source of meeting other people doing similar work that you're most likely going to get along with and have fun with.
Okay, great. So I'll address some of the other questions that are coming in, just related to R. So there was a question really about using two different data sources, one for the trained and one for the actual live data. Within Sisense, you can specify different data sources, and you can use that when in each visualization. So you can use components from both data mashed up, or you can use a single source to train and then another source to actually predict. So all the data is in one location, and it makes it easy for you to just specify which data sources you want to run that. Okay. Is there anything else you want to address, Jared?
Looking through the list of questions. Seems to be a lot of questions about learning R, so I'm happy to tell you guys the same answer about the meetups in the book. So someone asked, how is R different than reporting on the market today? So you want to use R, while you can use R for reporting, and there's very great ways to do it, the bulk of the reason to use R is for statistics. So I highly recommend, it does do reporting, and it also integrates into Sisense, which is this nice BI tool. But if you're really going to dive into R, I highly recommend using it for statistics and doing crazy models. Crazy models is the wrong way to put it, but doing strong statistical models.
Okay, great. There's another
someone
question
someone did ask some info on meetups in New York City. Meetup.com/nyhackr. That's NYHACKR. We'll get you information about the R meetup, and from there, we can direct you to other meetups like the machine learning meetup. Go ahead, Evan.
Okay. Sure. So there was another question about how does Sisense complement R. I think it's three things. Everybody's still looking at the presentation. There's two kinds of solutions around business analytics. So if we look at kind of like the complexity of data and agility, there's solutions that are agile that make it easy to work with data, but they don't deal with the complex components. And then there's those kind of older solutions that deal with the complexity but aren't easy to use. So Sisense gives you both, and specifically for R, it enables you to firstly centralize all your data, to automate in a very easy way kind of the data preparation steps, as well as a full platform to be able to visualize and explore that data as well. And we leverage the richness of R to do that. And another point in that regard, if anybody does want Sisense, it is a free trial on our website on sisense.com, and you can download it and start working with it. Okay, Jared, do you want to, just because we have limited time, you want to maybe just take two more questions relating to R, and then we can summarize from that.
There was a great question about, can we use R for data scraping? And absolutely. there are a number of packages that allow you to go through, and I assume this means web scraping, that make it easy to go through and pull data off a website or if through APIs. If you want interactive APIs, there's the HTTR package. And if you want to scrape from a website, there's the XML, XML2, and HVS packages. And they make it incredibly easy to pull data off of websites. In fact, I have a few examples on my website, jaredlander.com, of scraping the website of menus to figure out the average price of a slice of pizza. And it's very nice for scraping.
Okay, great.
And there's another. Go ahead.
Go ahead. Oh, go ahead, please.
But there's just another question. What material would you recommend to start in predictive analytics in R? Obviously, material. There's my book, of course, but starting simple. There's so much available on the web. rbloggers.com, rbloggers.net, I believe. rbloggers is a great source of material for modeling and everything about R. And this piece of advice is start simple. When you do your first model, do one predictive variable, then two, then three, and build it up very slowly.
Okay, we're just running out of time a little bit, so we are gonna answer all the questions, and you're more than welcome to contact us directly with your questions. So Evan and Jared, this was great. Thank you so much for your time. And thanks to all of you who took the time to join us for the webinar. The webinar will be recorded, so you'll always be able to log back into Bright Talk for a second look. Also, speaking of meetups, for those of you in the New York area, we're actually going to be hosting a meetup with Jared on the 9th of February on getting started with R and machine learning with JavaScript. So you can find that under Meetup as well, under the Data Science NYC group, and actually meet Jared in person. So that's something to put in your diary. Anything else you want to add, guys?
No, that'll be all. I'd really like to again say thank you to Jared. I think, as I said, I think he's an excellent teacher and very knowledgeable. We really appreciate him being with you today. And as Daphne said, we hope we see some of you, or hopefully all of you again at our other meetups or events that are held around ours.
Okay, great. Thank you so much.
Thank you to everyone attending, and thank you to Sisense.
Thank you, Jared. Okay.